Good morning. We'll start here with the polymers topic. Polymers topic, you will get 3 marks questions. And what this word stands for, you can check it. Polymers. It means number of monomers they are going to combine through covalent bond formation. And here it's written there, monomers, like for example, one example I'll take here, polythene. What this polythene stands for means number of ethene molecules they have combined. So different types of polymers we are using as a regular basis. You can say utensils we are using, or switches are there, like all that lighter body that is made up of like car, flight. All these things are made up of polymers material. Now we have to understand here how this is defined, because in this chapter you have to basically give stress on monomers of all these polymers, and all that chemical formula that's given there you have to do writing practice, because if you're going to make any mistake with the chemical formula, you'll be missing marks over here. So polymer, we said it's a chemical substance of a high molecular mass formed by the combination of large number of simple molecules. Like example, I told you polythene. Nowadays, you have to differentiate polymers from macromolecules. Like you just take example, I said polythene, and same time I'm saying protein. Protein is single molecule with higher molecular mass. It has not combined, like chote unit like have not combined. But in the case of polymers, smaller units they are combining and they result in the formation of bigger substance. So we can say here like this, polymers can be called macromolecules, but macromolecules cannot be called polymers. Remember here, always polymers combination macromolecules, what we are talking here, it's a single molecule. Like here, when polymer is obtained, that is also single molecule, then it will be called macromolecule. So now we are going to classify polymers here. Classifications, basically that is based on 4 different stages. You will say 4 different, not stages exactly, on the basis of 4 characters, different characters. First is on the basis of source, from where are we extracting. So natural, semi-synthetic, synthetic polymers are there. Then on the basis of structure of polymers, how are they? Sometimes they are connected through in a linear chain, or due to functional group, they are appearing as branch. That will be called branch chain polymers. Number of times when they are combining, they combine through different ends. That is called cross-linked. You will see examples. Then networking is also there. So all these examples you are going to see. Classification on the basis of molecular forces. Once that polymer that is made, so how these polymers are getting attracted to each other. Polymer has been made. How they are getting attracted, through which type of intermolecular forces, we are going to see it in this chapter. Then how are they combining? What is that mode of combination? What's the mechanism? So we find 2 types of mechanism. One is addition reaction, second is condensation. So we'll see what is there in addition and what is there in condensation. Now we are coming here on the basis of sources. We said natural means like it's nature, it is present. Example, you can say cellulose, starch, all these things are there. Semi-synthetic is what? Which is a little bit like that is mixed. All your material, like shirts material and all, that is made up of semi-synthetic polymers. Third is man-made 100%, like nylon 66, synthetic rubbers, Buna S and all these things are man-made material. All these examples that's given over there, carefully you have to see it. Next is classification based on the basis of structure. So first thing is what, when monomers are going to combine in linear chain form. All these definitions given in your slide. So those definitions, you have to write it separately. But beside definitions, you have to see that structure also, how this is going to take place. So linear polymers clear when monomers, they are going in single chain. Next is branch chain polymers. Branch chain polymers, we can see here where monomers, they are containing branches. When they combine, naturally they appear as a branch. Cross-linked polymers here, during combinations from the same single monomer through different functional groups. Number of functional groups they are going to combine, they result in cross-link. Third type, classification based on mode of polymerization. How do they combine? One is addition polymerization, second is condensation. Addition means this is possible in unsaturated compounds. And during combination, we have to see here that when two things are going to combine, monomers are combining. Monomers are combining, and same type of monomers are there. It's named as homopolymers. If different types of monomers are present, when they are combining, they are named as copolymers. Next is condensation polymers. What happens? First thing, two different types of molecules are there. When they are combining, first A and B, they will combine, they result in C. But during combination, small unit of molecules will come out, which is not there in the case of addition. Additions, simple 11th standard, what you have studied, addition reactions takes place through double bond or triple bond, you will say. On that basis, polymerization takes place. Here in this case, we are finding during combination, first two units, two chemicals, they are going to release smaller unit like NH3, water, or simple molecules, which you'll say. After that, they result in the formation of substance C. C combines with A once again. So this way it continues. That is called condensation polymerization. Now, on the basis of molecular forces, fourth classification on the basis of molecular forces. Which type of forces that is present? First is elastomers. Elastomers, we are finding that polymers, they are connected to each other through weak intermolecular forces of attraction. So if weak intermolecular forces of attraction, vulcanized rubber is example. So it's not going to be very strong. Next, natural rubber, you can say, which can be, you must be finding like it remains normally soft. It breaks easily because between polymers, with weak forces of attraction that is present. Next is here, like in this case, you'll find like addition, which I was explaining. Addition, you can see here how these monomers, they combine through free radical, that is explained in the slide. Condensation, how that removal takes place. Now, once again, we are coming back here. Fibers. In the case of fibers, we find this is this polymer, you'll find this is having like good strength. Why? Because between polymers, there'll be hydrogen bonding. Example, we can see here nylon 626, terylene polyacrylonitrile. So here, even clothes material also you'll find they are made up of fibers. What you say, it remains very strong. Third is thermoplastic. Thermoplastic, very weak van der Waals forces of attraction remain. So they melt fast, which sets on hard on cooling. So these things are there. Thermoplastic, polythene, polystyrene are example. Thermosetting plastic, you'll find normally it remains semi-fluid substance with low molecular mass. But when they are heated, they become hard and infusible due to cross linkages between the polymers chain. So bakelite, melamine, unbreakable substance which you're finding here that remains. One question normally remains for competitive exams also to do comparison with the strength in fiber, thermosetting, thermoplastic, and elastomers. You'll find fibers, they are the hardest substance, means the more durable you will say, then thermosetting, thermoplastic, and then elastomers. Now, classification based on mode of polymerization. Chain growth polymerization, that is addition polymerizations we have seen. Second is step growth polymerization or condensation. Like step growth and chain growth, these two words, what does it mean? Like ethene you have seen. This is very simple. Ethene is one molecule combining with another ethene with the addition reactions, and you are getting third compound which you are getting here, that is going to combine with another ethene only. It means it goes in chain. A combines with A, forms A type substance, and that's going to combine with A. It means ethene combining with ethene. Once again, we are getting like that is also B. That ethene is also going to combine with, means one part is going to combine with another part. Now this part is going to combine with same type of substance. That is called chain growth polymerization. But in step growth polymerization, what happens? A combines with B, results in the formation of C. Now C combines with A once again, and A combines with B, results in the formation of substance D. Now D combines with A, then A combines with B, results in the formation of E. So what are we finding here? Like I said, A combining with B forming C. It means it's growing. Step step by step it is changing, and then it results in the formation of big compound. And during this combination, small unit of molecules come out. That's why it is also called condensation. It has got mechanism. In mechanism, we are having free radical addition polymerization, cationing, anionic. But according to our syllabus, we are having only free radical addition polymerization. So we'll just see that example in free radical polymerization formation of alkenes. Alkenes formation, we have taken 3 steps are there, and this is very important for board point of view. You get direct question. First is what? Benzoyl peroxide is used. Benzoyl peroxide breaks homolytically in between oxygen and oxygen, forms free radical. That free radical is going to poke ethene molecule to show homolytic reason, so that there also free radical can be created. So once that carbon with free radical ready, it's going to attack, it's going to motivate, it's going to poke another alkene molecule. First of all, they create free radical. Free radical means the pi bond is going to break, and shared pair of electron is going to be that's going to be present on either side. And we know that new bond formation takes place. New bond formation takes place. It means overlapping of half-filled orbital is going to take place here once again. So it continues. Now, place at which we want to end, or like factory people or scientists, they want to end, they are going to stop supplying that chemical, and this C with C, another C with free radical, they combine and they just seal over there. Means 100 molecules combining, 1000 molecules combining, they have to end at which one place. From either side, C6H5 will go out, and that results in the formation of polythene. You can see this example, like in simple way, where that arrow which I have put here, it means bond is breaking, and that's going to make free radical. Free radical means single electron is going to come here, and then it's going to combine with another ethene. Ethene is going to create free radical. Then chain propagation. First step, substance which we have got, reactive intermediate, it's going to poke another alkene. Free radical is created once again. Chain termination, wherever you want to end, you have to create in such, you have to provide such temperature and pressure so that they are going to combine within themselves, and they stop after that. So we have to differentiate chain growth polymerization with step growth polymerization. It's going to be same like what you have studied. It proceeds by chain mechanism, that is step growth polymerization. We say equilibrium steps. We normally get 2 differences, so we have to take care of this difference also. One repeating unit is there. In that case, 2 species are taken, and small elimination takes place. Here in chain growth, monomers remain unsaturated. There, it's not necessary. We have to, bifunctional groups also can be there. This mode, in chain growth polymerization, you'll find the mode of polymerization leads to increase in chain length or chain growth. In this case, we find here functional group participates. They are independent of each other. This process is named as step growth polymerization. Tomorrow we'll take monomers of different polymers. Till here, you read it properly, and definitions part, like with the sources and all, be careful. You'll be getting question as a definition from that area. Thank you.